Welcome to second episode of Claude Code production series. Now the hooks, turning text rules into enforced behavior. In this episode, I showed why prose rules in CLAUDE.md are unreliable for hard constraints. You write never remove everything and Claude follows it most of the time. One session, it does not, and most of the time is not good enough for a destructive operation. Hooks are answer. A hook is a shell command that Claude Code executes in response to tool events. Before a tool runs, after it runs, or at specific lifecycle moments, hooks run outside the model. Claude cannot overwrite them, ignore them, or forget them because a long context. They execute in the shell regardless of what the model decides. In this episode, builds 3 production hooks from scratch: a destructive command guard, a compaction state save, and a test gate. By the end, you will understand the hook system well enough to build your own, and you will know the one technical detail that makes most community hooks silently fail. Before the code, let me show what hooks actually do and why they are structurally different from the CLAUDE.md rules. Here is the structural difference. A CLAUDE.md rule says do not run, remove everything, and force. Claude reads this as context. When the model is deciding what to do, this context influences the decision. If the model is a long session with a lot of competing context, or if the task at hand makes the rule feel less relevant, the rule gets less weight. It may not surface at the moment it matters. A PreToolUse hook says, before the bash tool executes, run this shell script. The shell script reads the command that was about to run, checks again the pattern list, and exit with either code 0, hello, or code 2, block with this error message. The model never sees a choice. The command either runs or it does not, based purely on what the shell script decides. This is not a question of model quality, it's a question of architecture. Constraints that must be enforced belong to the enforcement layer, the shell, not in the reasoning layer, the context window. The same logic applies to the automation. Saving tasks before compaction should not depend on Claude remembering to do it. It should fire automatically when the PreCompact notification event fires. Running the linter after file write should not be a CLAUDE.md reminder. It should be a PostToolUse hook on the write tool. If you find yourself with a CLAUDE.md rule that thinking this is really needs to always work, that is the signal that it belongs in a hook. To build hooks correctly, you need to understand the 4 event types, what each one can intercept. Claude Code exposes 4 hooks event types. PreToolUse fires before a tool runs. This is the enforcement hook. You receive the tool name and the full tool input, and you can block execution by exiting with code 2. If you exit 0, the tool runs normally. This is where destructive command guards, SQL injection guards, and file write restrictions live. PostToolUse fires after a tool run and return its output. This is the observation hook. You receive the tool name, the input, and the output. You cannot undo the tool call. It's already happened, but you can react. Run a linter, log the change, check the output for the patterns, send a notification. The test gate I built in this episode uses PostToolUse. It fires after a git commit command completes and fails the session if tests are not passing. Notification fires on session lifecycle events. The most important one for production use is PreCompact. It fires just before Claude Code runs context compaction. This is the correct place to save task state in a file. The event also converts other session moments like start and stop. For notification events, input is passed via environment variables rather than stdin. I explain exactly what that distinction matters in a few minutes. Stop fires when Claude finishes a turn and is waiting for the next user input. This is rarely useful for enforcement but useful for cleanup. Closing file handles logging session metrics, updating a status file. For most production Claude setup, you need 2 events: PreToolUse for enforcement and notification, PreCompact for state preservation. Let me show some example about PreToolUse and notification PreCompact here. For the PreToolUse, in the guards folder, we have destructive command guard sh. It intercepts bash tool calls before execution and blocks commands that match a list of destructive patterns. Claude Code shows exit 2 message to the user and stops agent loop. If you can go to GitHub and use this for your own sake, I would be appreciated. Look, there are patterns. For example, remove everything with folders and force, resetting the repository, pushing the repository to the origin, dropping some database table or database itself at all, truncating tables, deleting from tables, formatting some drive, DDing some drive. If you don't know, this command will erase a partition or writes to a partition, anything. So this was an example for the PreToolUse. Let's see a notification hook, Compaction save sh. It fires on notification. It's a PreCompact. Just before Claude Code summaries the context window, it appends the timestamp compaction marker to the task state.md, so the session history is recoverable. Look here, notification data comes, it writes to state.md, it creates if not exists, and append the compaction marker here. Alright, here is the technical contract. When Claude Code fires a PreToolUse event, it passes the tool information to your hook script via stdin as a JSON object. Your script reads stdin, parses it, makes a decision, and exits. Exit code 0 means allow. Exit code 2 means block. And whenever your script printed std out is shown to the user as a reason. This is simple. But here is where most community hooks break. For notification events, including PreCompact, Claude Code passes the event data via environmental variables, not stdin. If you write a compaction hook that reads from the stdin expecting JSON and gets nothing, it reads forever and hangs. Or it reads an empty string, cannot parse it, and silently exits with code 0, which means the hook ran but did nothing. The fix is to know which event type you are handling and read input from the right place. For PreToolUse and PostToolUse, stdin and parse.json access tool name and tool input fields. For notification, read environment variables, Claude notification type for event name, Claude notification data for the payload. The exit code contract also has one important exception. PostToolUse exiting with code 2 in a PostToolUse hook does not undo the tool call. The operation has already happened. It signals an error to the session, which may stop the agent loop. Use it as an emergency brake, not as an undo. One more thing, hooks run synchronously in the tool execution path. A hook that hangs will hang the entire Claude Code session. Keep hooks fast. If you need to do something slow, like a full test suite, run it synchronously and check the results in subsequent hook. For example, again, a PreToolUse hook is a select guard UI. It blocks any SQL tool call that is not ready to query except select with CTAs. Rejects everything else like insert, update, delete, or truncate. So it's wired to do Claude settings. There are allowed starts, write patterns, and in the end, look, blocked by select guard. So that was a PreToolUse. And a PostToolUse fires after a bash tool call contains git commit. Run the py test suite against the signal a failure if tests are broken. Basically, after a git commit, it tests all the application via unit tests. If anything fails in the unit test, it captures to every failure and show it to users. If it is passing, it exits with 0. And failed test, of course, return with exit 2. But does not undo the tool call. It's already run and it's committed. Now let us build the first hook, the destructive command guard. The destructive command guard is a PreToolUse hook on the bash tool. It fires every time Claude Code is about to run a shell command and checks it against a list of dangerous patterns before allowing execution. Here is the script. It reads stdin, parses JSON to the get the command string, and checks it against a pattern list. The patterns I use rm-rf or rm-r with any flags, which first one is forced to remove folders and the second is remove folders. Git reset hard, git push force, or git push f, which means git push force again. Drop table, drop database, any truncate commands. If the command matches any pattern, the hook exits with 2, with a message explaining what was blocked and why. The critical detail is the JSON parsing. The input from the Claude Code is a JSON object with a tool name field and a tool input field. For the bash tool, tool input contains a command field with the full command string. You parse this, not just read the raw line. The second critical detail is the check logic. You want to check the full command after stripping leading white spaces. Because Claude Code sometimes passes commands with indentation, you also want to check subcommands. A command that pipes through bash-c with a dangerous inner command should be caught. In practice, this hook adds about 2 milliseconds to every bash tool call. That is negligible, and it means that no matter how much context is in the session, no matter how complex the task is, no rm-rf ever runs without explicit user approval and nothing removed from the user's approval. To wire it up, you add a hook entry in the Claude settings.json with the event type PreToolUse, the matcher pattern bash, and the command path to the script. I will show the full settings.json structure in a moment. Let's go back and check again the extractor command guard sh. Look, it intercepts the bash tool call, read the full JSON payload, extract the command string, and there are patterns to block. We already shown it, and it returns either 2 or 0. Hook 2. The compaction state save hook fires on PreCompact notification event just before Claude Code summaries and discards the conversation history. Here is what it does. When a PreCompact fires, the hook writes the current task state to a file called task.json in the project root. The task state file has a simple structure: current task, what has been done, the next step, any open questions or blockers. The hook does not know what the current task is. Claude Code does. So the hook does something slightly different. It appends a timestamp marker to the file so you know when compaction happened, and it writes whatever the current CLAUDE.md says the task state format should be. Wait, how does the hook know what the task is in progress? Of course it does not. This is the design constraint. The hook can write a compaction marker and a timestamp. The actual task state must be written by Claude during session, not by the hook. The hook's job is to fire reliably and signal that compaction happened. The CLAUDE.md should instruct Claude to update task state MD after every significant step, so that when the hook fires, the file is already current. This is the correct division of responsibility. Claude maintains the state file during the session. The hook guarantees the file is not lost if the session ends unexpectedly or if compaction discards context before Claude can write it. The restore hook is simpler. It reads task state MD and session start and appends its content to the system context. This is not a hook, it's a pattern. The CLAUDE.md says at the start of every session, read task state MD if it exists and use it to understand the current task. Look, notification data comes from the environmental variables. Event type is Claude notification type. PreCompact appends timestamp to the task state MD. The third hook is the test gate, the most directly useful hook for a working engineering team. The test gate is a PostToolUse hook that fires after the bash tool runs a git command. It checks whether the test suite is passing before the commit is finalized in the workflow. I want to be precise about what it does and does not do. The git commit has already happened by the time PostToolUse fires. The hook cannot prevent the commit. What the hook tool does is run the test suite immediately after the commit, and if the test fails, exit with the code too. This signals an error to the Claude session, which causes the agent loop to stop and present the test failure output to the user. The intent workflow is Claude writes code, runs tests manually as part of the task, then commits. The hook is safety net that catches cases where Claude commits before tests are green. The script reads stdin, checks that the tool name is bash and that the command contains git commit. If both are true, it runs the test suite. If the exit code from the test suite is non-zero, the hook exits with 2 with the test output. If the test suite passes, it exits with 0. Of course, talked about that before. The performance consideration, this adds the full suite runtime to every git commit. For a fast test suite under 5 seconds, this is fine. For a slow test suites, like minutes, you want a faster subset. The hook can run py test with a -- fast flag or a specific test file that covers the changed code. The point is to catch the obvious failures, not to run the complete regression suite. Let's check back the test gate again. As you can see, it reads from stdin, checks the tool name, it checks if it is a git commit or not, it only acts on the git commit commands, and returns either 2 or 0. Now let me show how to wire all these 3 hooks into a settings.json. Each hook entry has 3 fields. Event is the event type, PreToolUse, PostToolUse, notification, or stop. Matcher is pattern that filters which tool or notification types the hook applies to. For bash specific hooks, this is the string bash. For all tools, this is an asterisk. Command is the shell command to run, usually the path to your hook script. For destructive command guard, even is PreToolUse, matcher is bash, command is the path to destructive command guard sh. For the compaction save, event is the notification, matcher is the PreCompact, command is the path to compaction save sh. For the test gate, event is the PostToolUse, matcher is bash, command is the path to the test gate sh. One important note about paths: use absolute paths in the command field. Relative paths are resolved from the project root, but if you move the project, relative paths break. Absolute paths are safe. On Windows, use forward slashes or escape backslashes. The shell that runs hooks is bash even on Windows when using Claude Code. The settings.json file also accepts a timeout field per hook. How many seconds to wait before killing the hook process? The default is 10 seconds. The destructive command guard and test gate both need enough time to run. Set timeout to 30 for the test gate if your suite takes longer than the default. Look, this is the settings.json. As an example, of course, there are events, matchers. As you can see, PreToolUse, matcher is the bash, and destructive command guard sh is here. And another PreToolUse, I've shown it before, the select guard py. It's a execute a SQL and its timeout is 10. So PreCompact, it's a notification, compaction save sh, and has the 10. So I made it 60. Maybe your test suite is take longer. So it's a PostToolUse and matcher is the bash. Let me close with the 4 things that determine whether your hooks are actually working. Here is the diagnostic checklist for a hook that's not working. First, is it firing at all? An echo statement at every start of the script that wires to a log file. If the log file is not being written, the hook is not being called. Check that event type and matcher settings.json are correct. A typo in an event name means the hook never fires. Second, is it reading input from the right place? PreToolUse and PostToolUse stdin notification environment variables. This is most common failure. A hook that reads stdin for a notification event will hang waiting for input that never comes. Then timeout. Then appear to have done nothing. Third, is it exiting with the right code? In bash, a script exits with the exit code of at least command run. If your last line is a grep command and grep finds no match, the exit code is 1 or not 0 or 2. Claude Code interprets any non-0, non-2 exit code as an unexpected error and an explicit exit 0 at the end of every hook. That means to allow the action. Fourth, is it fast enough? The hook that takes longer than the configured timeout is killed and treated as a failure. For hooks that runs test suites or slow operations, set the timeout field accordingly or run the slow operation asynchronously. The GitHub repo for this episode includes hook debug sh template that writes all relevant input stdin content, environmental variables, exit codes to a debug log file. Use it to diagnose and hook that is not behaving as expected. Paste the debug log output when asking for help. Let me show the hook debug sh. It's a universal hook debug template. Logs all hook inputs to temporary folder, so you can see exactly what Claude Code is passing to your hooks. Use this as a first step when a hook is not working. I mean, it's a hook debugger, basically. So as you can see, it's always allow, but this is only hook observes. All right, 4 takeaways for closing this episode. 1. Hooks enforce CLAUDE.md guides. Hard constraints like destructive operations, production access, commit gates, those are belonging in a hooks. CLAUDE.md is for context, not enforcement. 2. Know which event type you need. PreToolUse for blocking actions before they happen, PostToolUse for reaching after it and reacting after it, notification, PreCompact for state preservation, stop for cleanup. 3. Standard in for PreToolUse and PostToolUse environment variables for notification. This is the one detail that separates working hooks from hooks that silently do nothing. Get it right, and everything else falls into a place. 4. The compaction pattern is file-based. Claude maintains the state file during the session. The PreCompact hook guarantees the file survives. A new session reads the file. Nothing relies on the conversation surviving. The scripts for all 3 hooks are in the production Claude Code repository on the branch episode 2 hooks. The settings.json example shows exactly how to wire them. Episode 3 will cover the MCP servers, a completely different extension mechanism that adds new tools to Claude Code rather than gating existing ones. See you there, and if you like this, please subscribe and like the video. Thanks a lot.